So welcome everyone. This is 11.2 on complex numbers. We talked about what imaginary numbers are, and you guys already know what real numbers are, but we are going to define them right now. So what a real number is, it's a rational number like positive or negative integers, fractions, and irrational numbers. Okay? Okay, that's what a real number is. An imaginary number, class, is the product of a real number and the imaginary number. Remember, it's represented as I. Okay, so anything that has a product of a real number and imaginary number, like negative 5i, like 1 over 3i, like I square root of 2, or even pi I is an imaginary number. Okay? So what a complex number is, and that's what we're on today. What a complex number is any number that has the form a plus or minus bi. Okay, where a, this part here, a is the real part and bi is the imaginary part. Okay, so it's just a sum or difference of a real number plus or minus an imaginary number. Okay. So what I have for you today here is a Venn diagram of what a real number is. There's examples, yeah, of what imaginary numbers are and what complex numbers are. Okay, so what a real number is 17, 3 over 4, negative 5, square root of 2, pi, or 3.333333. Imaginary numbers 2i, negative 7i, I squared of 11. And what a complex number is, it's just the sum or difference of a real number and an imaginary number. Okay, so we get one from the real number, get a term from the imaginary side, and we just add it or subtract it. Okay, that's what a complex number is. All right, cool. So what we're gonna do today is we are gonna add them, we're gonna subtract them, and we're gonna multiply them. So when we're dealing with complex numbers and we're adding or subtracting them, we're just gathering the like terms. We're gathering the real part and we're gathering the imaginary part and we're doing their operation. Okay, and we're gathering the like terms. So here I have two examples. I'm going to do the first one first. So this is 16 plus 17i plus negative 8 minus 12i, right? So if I gather the real parts, it will be 16 minus 8 plus, if I gather the imaginary parts, 17i minus 12i. So 16 minus 8 is 8 plus 17i minus 12i, that's 5i. And here is my answer. Okay. Okay. So when we're subtracting, we have to remember that we're subtracting them. And what I like to do with the subtraction is get my subtraction and distribute it out. So then we have here plus negative 9 minus 10i. So I would have 17 minus 6i plus negative 9 minus 10i. If I gather the real parts, it will be 17 minus 9 plus gather the imaginary numbers, right? 17 minus 9 is 8 plus negative 16i, which we can say that it's 8 minus 16i. Now, what's in common between 8 and 16i? Eight can go into both of them. So what I'm going to do is I'm going to take them out. And what's left over is 1 minus 2i. Okay, when I take it out, when I factor out an 8, it's like I'm dividing by 8. Okay, so 8 divided by 8 is 1. 16 divided by 8 is, or 16i divided by 8 is the negative 2i. Okay? We need to get comfortable with taking out our common factor. All right? When we're multiplying them, multiplying complex numbers, remember that complex numbers, there's only two terms, right? There's only two things. There's a real number and a imaginary number, right? So we're multiplying two terms with two terms. We're just multiplying binomials. And we're going to treat I like a variable. Okay, so remember when we're multiplying binomials, I'm going to get the first one. I want to distribute it out to and multiply it out to the 4 and the negative 2i. Remember, when there's a negative in there, I have to get the sign with it. So 4 times 6 is 24. 4 times negative 2i is negative 8i. Do the same thing with positive 9i. Positive 9i times 6, that's plus 54i. Negative 9 times negative, or 9i times negative 2i, that's negative 18i squared. Right? Yeah, because I times I is I squared. Okay. I'm going to go ahead and I'm going to gather. That will be 24 plus, what's 54 minus 8? 46 I minus 18i squared. Do you remember what I squared is equal to? What is I squared equal to? Negative 1. So whenever I have an I squared, I can substitute in the -1 because I squared equals -1. So if I multiply that to the negative 18, right? If I multiply those two things out, -18 times -1, that's positive 18. And then 24 plus 46i. So 24 plus 18, that is 42 plus 46i. There's my complex number, right? There's my complex number right there. What is the common factor between 42 and 46? What can I take out of both 42 and 46? I'm going to take out a 2. So that's 21 plus 23i. Oops. Okay. And there's my answer there. All right. So here's another one. So I am going to get the -3 and distribute that out to the 7. So that's -21 times -3 times 4i. That's -12i. Do the same thing with the 12i here. 12 times 7 is 84. So plus 84i times 12 times 4 is 48. Plus 48, and then I squared, right? Because I times I is I squared. Now, here's the quick way to simplify I squared. I know I squared is -1. So what I'm going to do is I'm going to cross out that I squared. I'm going to cross out the sign, change the sign up. So that's -48 instead of plus 48 I squared, right? Gathering the like terms, -48 and -21. That gets me 69. -69. And then -12i and 84i plus 84i. That gets me plus 72i. Right? Now, what's in common between -69 and 72i? What's a common term? What's a common factor that I can take out of both 69 and 72? Three. So I can essentially divide this by 3. What is 69 divided by 3? 23. And if I divide 72i by 3, I would get 24i. Yeah, that would be my answer. Okay. So when we're multiplying or adding complex numbers together, we always come out with a complex number. When don't we come out with a complex number? Specifically when we're multiplying. Is the product of A plus BI times A minus BI, where A and B are real numbers, a real number, imaginary number, or a complex number? Let's take a second there and think about that and think back on the special forms that we've done. Okay. Do we all remember this form? If it's a plus b times a minus b, this is called the difference of squares. Right? That breaks out to be, if I multiply this out, I'll be left with a squared minus b squared. Okay, because that middle term of ab, they would cancel out. So if I literally just multiply this out, it'll be a times a, which is a squared, a times negative b, which is negative ab, b times a, which is positive ab, and I would be left with b times negative b, which is negative b squared, right? So if you see here, the negative AB and the positive AB, those two guys would cancel out, leaving me with a squared minus b squared, right? So if I had a plus a or a plus bi times a minus bi, if I multiply this out, a times a is a squared, a times negative bi is negative abi, bi times a is positive abi, bi times negative bi is negative bi squared, right? So again, these middle terms would cancel each other out. I'm left with a squared minus bi squared, correct? What is, oh, I'm sorry. It should be b squared I squared, because bi times bi is bi squared. B squared I squared. Okay. So what is I squared? Negative 1, right? I squared, remember, equals negative 1. So I'm going to take that away. I'm going to make this a plus, right? To switch up the sign. So we're left with a squared plus b squared. So my difference of squares here would equal a squared plus b squared. If I have two binomials with real numbers, I would have a squared minus b squared. Okay. All right. These two terms here are called conjugates. Conjugates are a binomial with the same terms right? A and B, those are the terms. But the signs, the operations are opposite. Okay, it's always going to be a plus and a minus. Okay, those are conjugates. whenever we use conjugates and we're multiplying conjugates, the I goes away. Or the square root goes away. Because we're squaring them both. Okay? We're going to use that skill later in this chapter. All right? So to end it, I want you guys to practice these two. And I'll give you guys about 2 minutes. So we are going to get the first term here. Distribute that out to the 3. What I like to do as well, instead of making those lines, is just go 6 times 3, which is 18. I like to just underline them. 6 times negative 10i is negative 60i. Negative 5i times 3 is negative 15i. And in the last one, negative 5i times negative 10i, that's positive 50i squared. Right? And now since we have, the I squared, which equals negative 1, I'm going to cancel that out. Cancel out this plus, make it a minus. Okay? That's going to be a minus. So 18 minus 50, that's negative 32. Negative 16 minus 15, that's negative 75i. There's nothing here that we can take out. Or we can factor out, so that's my answer. Okay? Cool. So if I do the same process here, 8 times 11 is 88. 8 times I, positive I, is positive 8i. 15 times 11, 15i times 11. Please do not go to your calculator for this. Okay, I know some of us are itching to go to your calculator for 15i times 11. Quick mental math. What's 15 times 10? 150. And you need another 15, correct? So it's 165 if I add 15 to 150. So that's plus 165i. And then the last part is 15i times I. That would get me positive 15i squared. Now this last part here, the I squared, again, is negative 1. So I'm going to cancel that out. Cancel out this plus, make it a minus. Okay? So I have 88 minus 15, which is 73. Plus 8i plus 165i, that's 173i. There is my complex number. Okay? Questions on this? Simple? Yeah. That is your lesson for today on complex numbers. I'll see you on the next one.